Hey guys, so welcome back to another video. I hope everybody's midterms went super well. So today I'm going to be talking about trig integrals and kind of generally how to go about thinking intuitively about these integrals. I don't think we should kind of rely on solely just formulas and theorems. I think it's also good to understand why theorems work and kind of the intuition behind theorems. That way, if we forget theorems, we still know how to do integrals, right? So the first thing I want to note is that now you're kind of expected to know how to do IBP and U sub as intermediate steps. So this is an example of where something like that shows up. So trig integrals, I have a very general case of the trig integral that you've been working with so far. We split them up into three cases according to the theorem, but the intuition behind it is it's just performing a U sub, right? The issue is when you do the U sub, right, you're gonna, for example, you're gonna U be cosine and du is gonna be negative sine. So you may have a bunch of signs left over after you substituted in that du, right? Well, then you're kind of stuck because if you have some signs left over, you're still going to have sines and cosines. U only counts for cosines. So what are you going to do with sines? Like all the other signs, right? So that's when you use this top identity. You can rewrite sine in terms of cosine, or you can rewrite cosine in terms of sine, right? So it gives you that these trig identities give you some leeway to kind of play with what functions are left over depending on what case you have here, where m is odd or n is odd. I think it's also better to think about your cases as, am I going to let u be cosine or am I going to let u be sine, right? So we're kind of building this intuition, not depending on the theorem, but just depending on our knowledge of, I'm going to treat this as a u sub, but first I need to rewrite some things, right? So that's kind of how we're going to use that first identity. For this last piece of the theorem down here, we're going to have that sine and cosine are both the same exponent, right? But when that's the case, we can actually, if they're both the same exponent, it doesn't matter if we let u be cosine or u be sine. No matter what kind of substitution or some type of identity that we try to mess with, using only this first identity, we're not going to get where we need to be, right? So that's why we have these very obscure double angle formulas. And I say obscure because these aren't really emphasized. So we have these two double angle formulas, and what they do is they allow us to write both cosine squared and sine squared in terms of just a different power of, or they let us write cosine and sine in terms of just cosine. And not only that, they let us write cosine squared and sine squared in terms of a cosine of a linear function, right? So that's super convenient for us because that's a very straightforward integral to do if we do that substitution, right? So this is where we would use these two bottom identities, but it's the same case. What our trig integrals, the basic steps for is, okay, what do I want to be u and du? How do I rewrite my integrals using trig identities so I can successfully have only u and everything can be represented by u? So yeah, that's kind of the intuition behind it. I hope you guys start thinking about this more. Yeah, I hope you learned something. Thank you guys for watching.